Okay, this is term 1, week 2. Welcome to your first mechanics AMS, guys, or applied math, whatever you want to call it. I will be calling it mechanics on my YouTube channel. Um, Starting off, just so you guys know the layout, for this year, I will be taking a different approach with the videos. I'm gonna start by saying I won't be only recording the quizzes. At the start of each video, I'm gonna have my notes. Okay, I'm gonna go through them really quickly. Okay, you can skip through it, it's fine, but I'm gonna go through it because and I take down the important parts. Okay, obviously I'm not gonna go over the questions that I solve, but just the notes that I take down. After that, I'm gonna solve the quiz, and then after that, we're gonna do a few grid questions because the grid questions are the ones that always come. 95%, uh, 95% of the exam always comes from, and the 95 was the 80% of the exam always comes grid questions. So you have to memorize the grid questions. You don't have to know them. So you can skip to the quiz. I'm going to start now with the notes. Chapter 1. This isn't in the mechanics book. If you want to read the book for it, it's an SDP document in the exam preparation. Go to term 1, week 1, mechanics. There's a document called vectors, and it's basically the book. Okay, but it's an old book. So, and I'm going to start with my notes. Chapter 1 is all about vectors. Okay, you guys know that a vector always has a magnitude and a direction. Why do we call it vector? Because why do you call it vector, not scalar? Because it has a direction. Scalar only has a magnitude. And you know what magnitude is? Magnitude is when some number in a unit, for example, 4 newtons, 5 meters per second, 12 watts, and so on and so forth. Any vector AB is denoted AB with the vector symbol above. وكمان it's denoted by point A, point B. We connect them. This is called the tail over here, and this is called the head. Okay, with an arrow. When are two vectors equal? Two vectors are equal if they have the same magnitude and direction. When do we call a vector 0? When it has a length of 0 and an undefined direction. When are two vectors parallel? Okay, when the lines of action are parallel. When are they opposite? You say that vectors are opposite if they have equal magnitude but opposite direction. Unit vectors, obviously, unit, always associate unit with 1, okay? So unit vectors is when the magnitude is 1. How do you add two vectors? I wrote the triangle method here. There's also the parallelogram method. To add two vectors AB and BC, AB plus BC is always equal to the first letter and the last letter, so AC. Okay, that doesn't really matter, but how you can denote, how you can represent it graphically. AB, if you want to add AB, okay, let's call this AB, and let's say let's call this, instead of AB, I'm gonna say vector U and vector V. Okay, let's say I want to add these two. Okay, the first thing you would do is you would connect the head of the first vector to the tail of the second vector. So we're gonna rewrite it like this: vector U. Don't forget vector symbols. If in written part you don't put vector symbols, you will lose 0.25 marks. You'd connect the head of the first one to the tail of the second one. So you're going to connect it like this. This is the first thing. Okay, so this is U, this is V. And I want U plus V, صح? How would it be? Now, from V, you connect... not from V. From the tip of U, you connect it to V. This would be U plus V. Very easy. This is called the triangle method. For the triangle method to work, it should be the tip of the arrow connected to the tail. Okay? So the head connected to the tail. The other method is what we call the parallelogram method. Let's say I have vector U like this, and I have vector V like this. Okay? Here, you realize that the tail is connected to the tail. It's not tail and head. So obviously we can't just do this, because then this would be wrong. To do this would be the triangle method. To do the triangle method, you need to have head connected with tail. Now we're going to do now another method I'm going to show you. It's called the parallelogram method. What the parallelogram method does, it's basically you dot this and you dot this, you extend it, and you just extend this like this. You draw a line in the middle, and this is called u plus v. Okay? That's the parallelogram method. You extend the other two, and you draw a line to the middle. Okay. These are a few rules. Okay, whatever. These are easy. I mean, they're pretty self-explanatory. U plus v can be written as v plus u. V plus 0 is equal to v. V plus minus v is obviously the same as v minus v, which is the same as just 0. Any number times minus v is the same as saying minus that number times v. These are all alpha. You don't really need them. Okay, Cartesian coordinates. Any vector v can be rewritten as, let's forget about the k, can be written as ai plus bj. I is the x, j is the y. It's the same as saying minus 2 comma 4. The vector minus 2 comma 4 is the same as saying minus 2i plus 4j. Okay, this is the same thing. Don't get confused. What's I? What's j? No. All that it means is the x goes with I, the y goes with j. Okay, very easy. So, anytime you see a vector, you're going to see it a lot, the I and the j. Then you have the column notation. مش صح, we said we can write it as minus 2i plus 4j. You can also write it as a column notation. Vector, let's say vector v. Yeah, you can also write it in the column notation. It will be the x up, the y down. It's the same thing. Vector v is this. Same thing. Here, what do we have? This is just subtraction. See here, I didn't put the vector symbol, and I lost marks for it. If this was the written part, my teacher came and corrected it for me. Please make sure to put the vector symbol if you have periodic. Next week, we will have periodic. Okay, magnitude of a vector. This is from grade 10. To find the magnitude of a vector, okay, the magnitude of... the magnitude of any vector, let's call it u, with components ai plus bj, would be radical a squared plus b squared. So let's say I have a vector v. This is a very famous one. 3i plus 4j. So, essentially what they would ask you is find the magnitude of this vector. And to find the magnitude, all you have to apply is the formula radical, if it's the coefficient of I squared plus the coefficient of j squared. So in this case, it will be 3 squared plus 4 squared equals radical 25, which is 5. Okay? Basically like the Pythagoras theorem. Okay, then the unit vector. This formula, many people, they tend to forget it. Okay? To find the unit vector u is equal to, let's say the vector v is ai. Okay, let's call vector v, to help you understand this formula. Vector v is equal to ai plus bj, right? Something with I, something with j, right? How would I find the unit vector of v? Step 1 is find the magnitude of the vector v. Let's say, and I gave you the magnitude of the vector v is 5. And you know what? I'm going to call the vector v 3i plus 4j. طب هلا I'm going to ask you, find for me the unit vector v. Okay. The unit vector u is always equal to the formulas here. The vector v over the magnitude of the vector v. What do I mean? What is the vector v? The vector v is 3i plus 4j. So 3i plus 4j. And what is the magnitude? 5. What does this mean? It means I have to divide the x component by 5 and the y component by 5. What is the x component? Is 3i. So we're going to do 3 over 5 I plus 4 over 5 j. To do it quickly, the vector, they give you it fast. You divide by the magnitude. That's it. You divide each component by the magnitude. So usually in physics, they don't ask you to keep it as a fraction. They ask you to give it your answer as decimals. For this will be 0.6i plus 0.8j. Okay. Let's see. Polar coordinates. Okay. This is very important. These 5 are very important. This, you have to memorize it because I know it will come. I know it's in the quiz. I know it will come in the exam. Either they're going to ask you about the formula, what is the formula, or they're going to ask you to apply the formula in a certain question. Look, let's say we draw it on a drawing sheet. I don't know why I still haven't drawn for you guys. let's say this is my y coordinate, and this is my x coordinates. We know that the x coordinates are in terms of I. This is 1, 2, 3, 4. This is 1, 2, 3, 4. I'm going to continue to use the example of 3i plus 4j because it's the most famous vector in my opinion. I like to use it a lot. So 3i will be 3 to the right, so it's over here. And then 4j will be 4 up, so it's going to be over here. Right? And it's a vector, so you connect it. Okay, we're going to call this 3i plus 4j. Or let's call it vector u. Okay, vector u, we're going to call it 3i plus 4j. So, we have another way to write this vector u. This is what we call Cartesian coordinates. Now I will show you polar coordinates. To find the polar coordinates, again, there's an x component and there's a y component. The x component, it's r cosine theta. And then the y coordinate will be the same exact thing, except instead of cosine, what do we have? Sine theta. I'm sure most of you are familiar with this from when we had forces. R being the magnitude of the vector, and theta being the angle between the x-axis and the vector itself. Remember, the angles start at the x-axis and go up counterclockwise. So if I were to tell you 50 degrees, it would look like this, 50 degrees. Not like this. Remember, it starts at the x-axis and it goes counterclockwise. So this one will be correct. Later, we're going to do bearings, and bearings are different. I'll explain bearings when we get to bearings. Let's stay here. So let's continue with our example of 3i plus 4j. How would I find the polar coordinates of it? Here's what we do. There's two steps we have to find. We need to find the r, right? We know the polar coordinates are r cosine theta and r sine theta, صح? So we need two things. We need the r and we need the theta. How do we find the r? R is very easy. It's the magnitude, right? So we do radical 3 squared plus 4 squared. Oh, you get 5. So r equals 5. Halla, to find theta. Theta has 4 cases. We're going to start with the most basic one. The most basic one is shift tan y over x. And in this case, it will work in this case. We just do shift tan of 4 over 3. And you get approximately, I think, 53 degrees. You get approximately 53 degrees. That's what I remember. So this is the first case. Theta equals shift tan y over x. What is this case if x is positive? All right? If x is positive. Okay, what about the next cases? The second case is if x is negative. If x is negative, you do normally shift tan y over x, but you add 180. So you're going to tell me, Walid, is there any way you can explain this to me? Do I just have to memorize, or is there any way I can understand? Let me show you. Theta is the angle in between the vector and the positive x-axis. So let's say I have this is minus 3i plus 4j, right? The x is negative, the y is positive. We're going to call it vector u. We know that if you find the magnitude, it's going to be negative 3 squared plus 4 squared under the radical, which is 5. Okay, so I found my r, it's 5. How about the theta? Would it be the same thing? Shift tan 4 over negative 3, right? Shift tan 4 over negative 3. Let's try it. Shift tan 4 divided by negative 3. You get negative 53 degrees. Let's see, negative 53 degrees. So negative 53, it means to go down, right? We said that angles start at the x-axis over here, right? And they go up counterclockwise. They go counterclockwise. If it's negative, it's basically telling you to go down. So it's basically telling you to go down. This would be here, negative 53 degrees. Is this the angle I'm looking for? Obviously not, right? So that's why we came up with the rule that if x is negative, you add 180. So let me show you now. Let me add for you 180. I get 126 degrees. Is this correct? Let's see. We start over here. We go up here. Now it's 90 degrees. We move just a bit more and we add this about 36 more degrees. Now this is 126 degrees. This looks like 126 degrees. And is it the answer we got? Yes, it is. So that's why if x is negative, remember you're going into another quadrant. A quadrant, this quadrant 1, 2, 3, 4. You're going to another quadrant. So when you're going to another quadrant, keep in mind we're adding 180. Okay. When the third case now, theta is equal to 90 degrees. When is theta equal to 90 degrees? Again, Anna, I don't like letting you memorize. I want you to understand. When is theta equal to 90 degrees? So when do I have this angle like this? That means the angle between, this is the x-axis, this is the y-axis. That means if it's 90 degrees, then obviously my vector is going to fall over here, right? Where the angle ends, it's going to be over here. And when it's over here, it's on the y-axis. What does that mean when it's on the y-axis? Obviously, it means x equals 0, right? There's no x here. So this could be مثلا 2. This could be 0i plus 2j, right? Over here. This is x equals 0. Okay, so when x equals 0, we said theta equals 90 degrees. Okay, طب وليد, what if it's 270 degrees? X also equals 0 when it's 270 degrees. Let's see. This is 90, 180, and then 270. مش here كمان x equals 0. طب وليد, what's the rule? Okay, what's different between, let's call this vector u over here and vector v over here. What's the difference between u and v? X equals 0 in both of them. How do I know the difference? Okay, what's different? Here, y is positive, right? Y is a positive. Here, y is negative. So when y is positive and x equals 0, then theta equals 90 degrees. And then when x equals 0 and y is less than 0, y is negative, then theta equals 270 degrees. Okay, just quick notes. I don't want to take too long in the notes. 16 minutes. Okay, let me continue. Okay, by the way, you can find polar coordinates on the calculator. Okay, let me show you. Shift polar of مثلا if I have the vector 3i plus 4j, right? 3, 4. And it will give you what r is equal to and what the angle is equal to. Also, I'm not sure if it works with the negative though. Let me see. Shift polar negative 3, 4. Oh yeah, it also works. See? So you can use the polar function, but in case it comes on the written, you have to show your work. Relation between polar and Cartesian. Okay. Okay. This is how to find. Okay, yes, we did this. Okay, هلا bearings. Bearings is, again, angle. We did this in math. A bearing starts with north. We have north, east, south, and west, right? The bearing starts at the north and it goes clockwise. So the bearing is different. It doesn't go counterclockwise and it doesn't start at the x-axis. The x-axis in this case would be east, but we're not starting at east, we're starting at north. So know the difference. Bearings, for example, a 45-degree bearing would be starting at north, going clockwise over here. This is a 45-degree bearing. This is how 45-degree bearing looks. So let's read our notes. Bearings are used by aircraft navigators. They could ask this question in the exam. Okay, what is a bearing used by? You could say aircraft navigators. Okay, these questions, the regional always likes to bring these definitions. Okay, it's used by aircraft navigators and it's another system of angles for giving directions. It is the clockwise angle of the direction with respect to the north. These ones you can memorize them. Obviously, north is 0 degrees. Obviously, east will be 90. Obviously, south will be 180. Then west, I don't know why I didn't put west. West will be 270. And so when they ask the questions for bearings, they ask them in a weird way. Okay, for example, they ask it like this: east 30 degrees north. When you see these types of questions, this is how you solve. You start with the direction they gave you. Let me scroll up a bit. You start with the direction they gave you. They said east 30 degrees north. What's my first direction? East. So بروح على east. Okay. Then they say 30 degrees north. So then I move towards the north. North is up. So I move up. How much? 30 degrees. So I go from east. I move north 30 degrees. So it's gonna look something like this. This is the bearing. Let's try south 60 degrees west. So I go to south. And I go 60 degrees west. West is to the left, right? So we go now to the west. This is 60 degrees. 60 degrees like this. There you go. Then sometimes they ask you, convert it in terms of north, south, east, and west. Sometimes they tell you 120 degrees. What is it? and we convert it into like into two directions. A bearing of 120 degrees. Here's how I solve it. I'll give you my personal way. My way, the best way for me, if you have a scratch paper, draw this north, south, east, west, and draw 120 degrees. We know that the bearing starts at north and it goes clockwise. So 120 degrees would look something like this. Okay, this is 120 degrees. Okay, then I ask myself, okay, what can I, in what ways can I say, what can I call this bearing? I could say I could say east, right? I could say east. We know this is 90, so this is obviously 30, right? If this is 90, then this is 30. I ask myself, okay, what can I say? I could say east, 30 degrees south, right? I could go start at east, then I go 30 degrees south. So you could call this east, 30 degrees south, or I could say south, because if this is 30, then this is obviously 60, because you know they add up to 90. Okay, or I could say south, 60 degrees east. Doesn't matter. But that's just the way in case they gave you the degree. These are not in the quiz, but they are all exercises in the book. That's why I want to go over them. Just so, like, see here, 90 degrees is east, 120 degrees is south, 60 degrees or east, 30 degrees south. These are all, exercises from the book. The regional always likes to get exercises from the book. The distance formula. The distance formula is very important. Let's say I have 2 points, A, x1, y1, and B, x2, y2. The distance is equal to radical x2 minus x1 squared plus y2 minus y1, also here squared. So here, the distance between 2 points and A and B is magnitude of the vector AB. Okay, yeah, obviously the distance between A and B is obviously the magnitude of the vector AB. The magnitude of the vector AB would be, this is the same thing I just wrote up. My one is a bit easier. This is more in terms of mechanics, the definition they gave. Then use this, and I recommend this one. It's easier for you to memorize. And by the way, the order doesn't matter. It doesn't matter if you have x1 or x2 first. It really doesn't. As long as you have the x's together and the y's together. That's what matters. The midpoint formula, it doesn't matter because you're squaring it anyway, so it's going to become positive. The midpoint formula, the midpoint m of AB, let's say I have A x1 comma y1 or B x2 comma y2. The midpoint of AB, the midpoint m of AB would be x1 plus x2 over 2. بعدين y1 plus y2 over 2. كمان the order does not matter. It really doesn't. هلا equation of the line. This is where it gets a bit tricky because people get confused here. If you want my advice, I recommend just take it step by step. The equation of a line passing through a point M and the position vector, I don't know why I put A is here, position vector A and parallel to a line D is given by this. How do they ask the question? They tell you a line, they tell you a vector A, they say there's a line L. Okay, they say there's a line L that passes through, wait, hold up. That passes through a point M of position. Yeah, they tell you there's a line. Okay, it passes through a point M, and its vector, they tell you its position vector. Okay, they tell you it passes through a point M, and the vector of M, it passes through L, so it belongs to L, and its position vector, there's a line L plus, let me rephrase it. There's a line that passes through M, and that M has a vector, let's say 2i plus 5j. Okay, M and its position vector is called A. Okay, and then they say that this line is also parallel to this line D, which is equal to, I don't know, 7i plus 3j. Okay, they ask you to find the equation of that line. Very, very easy. Okay, you take, this is the equation, your original vector plus t times your new vector, the parallel vector. Okay, this is when you have 1 point. So for example, let me go to the book here. The book here, equation vector equation. Yeah. So here they say ما في yeah. So they say it passes through the point M, and they tell us that the vector M is 3i plus 4j. Then they say it's parallel to I minus 2j. Just very easy. Apply the formula. The original vector, the new line, let's call the new line u. The new line is equal to u is equal to the original vector 3i plus 4j plus t times the new vector I minus 2j. You can tell me, Walid, what's t? T is a constant. You just distribute it. Here you can distribute t and then solve, or you can take my way. What I like is what I like is, you know, that your answer will have a I component and a j component. Your answer will always have something in brackets I and then something in brackets j. Okay, I'm telling you from now. So how I like to do it is I take the i's, yeah, look at the I keep the I outside. You see how we took it outside? What I take is the numbers that are with I. You keep them separate. So like, see here, what's the I? The I is 3, so I put 3. Here, what's the I? It's just t. Here, in the second number will always have a t beside it. Okay? So we took the I out, and here it's 1. So it's 1 times t, so it's just t. Here, my j. Now, 3 plus. My j, yeah? You take the j out, like we put here, and you can just put 4 plus t times minus 2 2t. Okay? That's how you can do it. Or you can do the long way where you have to distribute or whatever. So why it's a bit annoying is because here there was no number, there was no coefficient for I. So let me go through this again. The answer, you know, here when you get to this part, it's very easy. You have this I component, you have the j component. Okay? For the I component, you take the first number, 3i. Then the second number, t times I, it's ti. So we take the I away, so it's just t. Then the second one, you take the first j, which is just 4. Then you take t times minus 2 minus 2t. That's it. Okay? You leave the I and j outside. So see here, it's 3 plus ti, 4 minus 2t, j. Okay, then you have the equation for 2 points. For 2 points. For 2 points, it's very easy. Let's say you want to find the equation of a line passing through P and Q. Okay, it's very easy. You take the first point, okay, you write it down, plus, again, T, we're always using the T for equation of line, the second point minus the first point. So let me show you the exercise in the book. Okay, the exercise in the book. Here, what is the equation? Yeah, what is the equation of the line that passes through A and B? Okay, and then forget about the belongs part. Let's solve A and B. The line that passes through A and B. We said you write down the first point. So 2i. The formula is D equals the first point, right? Plus the second point minus the first point. T outside always. T times the second point minus the first point. The first point is 2i plus minus j, minus 1j, right? Or you could just say 2i minus j. The third, then you do plus, right? T outside. Second point minus first point. 0 minus 2 is negative 2i. 2 minus minus 1 is 3j, right? Now, what can you do? What did I tell you to do? Your answer will always have I and j, right? I and j. What is my I? 2. First 2. What's my other I? 2 times minus 2. T times minus 2 is minus 2t. Next, for my j, let me move it a bit to the right. For my j, my first j is minus 1, right? So minus 1. What's my second j? T times 3, 3t. Is that the answer? Yes, minus 1 plus 3tj, and you have 2 minus 2ti. Okay, Then they asked, does the point 6 minus 7 belong to D? This is not very important, but I will show you how to do it in case it comes. What you do is you substitute this, there has to exist a value for T that satisfies both equations. You have 6 comma minus 7 for C, right? You want to see if this C is on this line. 6 comma minus 7. How do you know if it belongs? You have to see if when you solve this equation for x and this equation for y, you get the same answer. Let's see. 2 minus 2t equals 6. You take 2 to the other side, you get minus 2t equals 4. You get t divided by minus 2, you get t equals minus 2. Then here, minus 1 plus 3t, let's equate it to negative 7. Because this is the x, right? You know, I is for the x and j is for the y. Okay, minus 1 plus 3t equals minus 7. Minus 1 to the other side, you get, you get 3t equals minus 6. And then you're going to get t equals minus 2. Are they the same answer? Yes. So since they're the same answer, C belongs to D. So they could give you a question, and you can easily give you in the AMS, find the equation of two that passes through 2 points, and then they ask you, does this point C belong? You could say yes or no, just so you know what to do. I think we're done. Oh, scalar products. Okay, scalar products are very easy. Mechanics. Okay, for scalar products, I'm gonna show you. I'll show you the easy formula, and then in the quiz, I'm gonna show you the formula that needs a bit more memorizing. If you want to multiply A times B, A dot B, we call it the dot product. Okay, A times B is this. You multiply the x components plus the product of the y components. So it will be A1 times A2 plus B1 times B2. Okay. We have some notes. If A times B is greater than 0, then the angle in between them is acute. If A times B is less than 0, then the angle between them is obtuse. But the most important one, if A times B is equal to 0, then it's 90 degrees. And I'm pretty sure they're going to ask you something that has to do with this last one over here. Okay? Because it came in the book and our physics teacher told us pay attention. It came before. These properties are not really important. I think we're done. Let's start with the quiz. Okay? This is a vector A. Which of the following vectors have a scalar product with A equal to 0? Obviously, we know that the product, okay, when is it equal to 0? When is it equal to 0? We said now. When the product is equal to 0, that means the angle between them is 90 degrees. So, what does it mean when it's equal to 0? That means the vectors, when they're beside each other, the angle between them is 90 degrees. So let's see. Let's connect this one here. What's the angle between them? 90 degrees. How about this one over here? What's the angle between them? 90 degrees. So that's why these two are my correct answer. They're the ones that will form a 0 dot product. Question 2. You have R1, 15, 2, and R2, 3 minus 4. And then they want you to find the vector of R1 minus 4R2. So whenever solving like this, I like to use the column notation. I like to use it like this. R1, which is 15, 2. So we write 15, 2. Okay. Minus, right, 4R2. So 4 times R2. So you multiply up and down. Don't forget, up and down. R2 is 3 minus 4. So 3 minus 4. Right? Let's continue. 15, so it becomes 15, 2. Minus 4 times 3 is minus 12. Okay, minus 4 times minus 4 is 16. And we're adding them, right? We're just adding. So 15 minus 12 is 3. 2 plus 16 is 18. So what is my x component? My I is 3i and my j is 18j. So 3i plus 18j. A vector is given by 9i plus 40j. V can be expressed as V as r, comma theta, where r is the magnitude and theta is the counterclockwise angle from the positive x-axis. So basically, they're asking you to find the polar coordinates. If you have calculator, do not waste your time. Go straight away. Shift, pole, 9, comma, 40, bam. R equals 41, theta 77 degrees. That's it. because they said to the nearest integer, huh? So you don't put that SMS. Okay, consider the two vectors A and B shown below. How will you add these two vectors? Remember, I told you there are two different ways. If you're working with the arrow and then it's the head of the arrow connected to the tail of the arrow, then you use the triangle method. But here, in all of them, the head is not connected to the tail. It's the tail connected to the tail. Remember, when I told you the tail is connected to the tail, then the only method you use is the parallelogram method. You extend this one and you extend this one and you connect the middle halfway through. Why is this wrong? Because they didn't extend to the other side. Okay, if they extended it like they did in the third option, then it would have been correct. Question 5. You have r 8 minus 15. What is the magnitude? Quickly, you just do radical 8 squared plus. Please make sure to put the negative 15 inside the brackets. If you don't put it inside the bracket, it will give you a different answer. Okay? And then the square outside the bracket, of course. You're going to get 17. Question 6. Consider the vectors A and B. What is the scalar product of these two vectors? Remember that the product of two vectors is the x components multiplied by each other, the sum of the product of the x components plus the sum of the product of the y components. So my x components are 3 and 2, so 3 times 2 plus my y components minus 4 times I. So minus 4, should I as the 8 minus 4 times 8. And you're gonna get negative 26. Well, what's the other answers? Yeah, 26. Okay, here we have a few vectors. We want a vector that is equal to A. So A is going to the top right, and you could say it's about 2 squares long. What is equal to it? Remember, when a vector is equal to another vector, that means it has the same magnitude and it's going in the same direction. So which one has 2 squares and is also going in that same direction of A? You could say H, right? So we can put H. A vector opposite to H. One or two vectors opposite. They are opposite when they have the same magnitude, so the same size, but opposite directions. So which one's 2 squares but going in the opposite direction as H? There's no other one other than H as they be here. A vector parallel to D. If two vectors are parallel, that means they are going in the same direction. So D is going up. Which other vector is going straight up? F. So F. A vector that is a scalar multiple of D. When we say something is a scalar multiple of D, that means they're going in the same direction, but the only difference is that one is bigger than the other. So which one is going in the same direction as D, but is just bigger than D? Again, F. You see, F is 2 squares, D is 1 square. Which one is a unit vector? Unit vector meaning its magnitude is 1. Which one here is just 1 square long? It's D. Do not say E. E is not 1 unit long. This, I'm going to prove it to you geometrically. We know the square is 1 by 1. Okay? And you want to know how much this line going through the middle. This is not equal to 1. If you have 1 here and 1 here, you do 1 squared plus 1 squared and put it under radical to find the hypotenuse because this is a right angle. You're going to get that this is 1 radical 2, not 1. This is a very, very common mistake students make. They're going to say E is the unit vector. No, because it's going diagonally. It has to be straight. Okay? Hatta if it's going like this would also be correct because it's along the straight line. Okay? But diagonally, it does not work. The sum of two vectors, A and something on this diagram, is equal to a 0 vector. So A plus what gets you a 0 vector? Obviously, to add something and get 0, that means you added its opposite, right? So like 2 plus what gets me 0? Negative 2, right? X equals negative 2 because negative 2 and 2 are opposites. So what is the opposite vector of A here? It's obviously B because it's going in the opposite direction but the same magnitude. So obviously A and B are the opposites. So when you add A plus B, you're going to get 0. Question 8. The two forces acting on a particle given by F1 is I minus 2J and F2 equals 2I minus 2I plus 6. What are the components of the resultant force F? The resultant force. How do you find the resultant? You add up the X components and the Y components. What's I plus 2I? 3I. What's minus 2 plus 6? 4J. Obviously, don't forget the unit. It's newtons. Remember, when working with vectors, you always need a unit. What is the magnitude of the resultant force? Again, to find the magnitude, we do radical 3 squared plus 4 squared. Like I told you, this vector 3i plus 4j, you're going to see it a lot. Okay, so it gets to a point when you keep on solving these questions, you memorize them, you know that the magnitude it's 5 and the angle between them is 53. But for those who don't know how to find the angle between them, remember you do shift tan y over x. Because x is positive, you don't have to add 180. It's just shift tan. So shift tan y over x, you're going to get shift tan 4/3, which is 53. Okay. Question 9. You have vector v 9i plus 3j. What is the unit vector in the direction of v? Remember, to find the unit vector u of any vector, it's the vector itself divided by the magnitude of the vector. First, we have the vector, but we need to find the magnitude of the vector. How do we find the magnitude? It's radical 9 squared plus 3 squared. Okay, and if I'm not wrong, you get 3 radical 10, right? 9 squared plus 3 squared, 9 squared plus 3 squared, then radical. You get 3 radical 10. So this is the magnitude. 3 radical 10. So we could say magnitude of v. So now can I find the unit vector? Yes, I can. So the unit vector u will be equal to the vector v, 9i plus 3j over 3 radical 10. So obviously, we're going to get the x component 9i over 3 radical 10. So 9 over 3 radical 10 I plus 3 over 3 radical 10 j. And of course, you need to actually calculate what this is. So let's see, 9 divided by answer. My answer was 3 radical 10. You're going to get 0.948. They want it to the 2 decimal places. So it's going to become 0.95 I. And then we want 3 divided by 3 radical 10. 3 over 3 radical 10. It's going to be 0.32 in this case, right? Because it's 2 decimal places, 0.32. Okay, then they want the angle of elevation of the bullet, blah, 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 blah. And I got, 18 degrees. I got this wrong the first time because I used the unit vector. نحنا شو خصنا بالunit vector? We want to know the angle of elevation. The angle, we do shift tan y over x. Did we say anything about doing shift tan with the unit vector? No, we didn't, right? So we simply use the normal vector we had. So 3 shift tan of 3 over 9. 18.4. They set the nearest degree, so 18 degrees. Question 10. Okay, you have the vector v, which is xi plus yj. I and j are unit. Okay, blah, 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 blah. This is the rule for theta. When is that arc tan means shift tan? Okay, shift tan. When is theta equals to shift tan y over x? We said when x is positive, so when x is greater than 0. When do we add 180? We said when x is negative, less than 0. Okay, when is it equal to 90? We said when x is equal to 0 and y is positive. Remember, when is it equal to 90? When is it like this? One is the point over here. When x equals 0 and y is positive, so y is greater than 0. Okay, and when is it equal to 270 degrees? 270 is like this. When is it over here? Again, x equals 0, but this time y is negative, less than 0. If x equals 28 and y equals minus 45, the polar coordinates of v, what are they? Can you do this on a calculator? Let's see. I want to make your lives easier so we don't waste time in the exam. Shift polar 28, comma, minus 45. Theta r equals 53, theta equals minus 58. Just like this. In 3 seconds, you solved. No, this question should not take you more than 45 seconds. If you can do it on a calculator just like this. Question 11. Okay. We have the vector r. They gave it in polar coordinates. R is 73 meters and theta equals 49. The position vector opposite to r is given by... Okay. So, actually, they want us to find it in Cartesian coordinates. So we want to convert from polar to Cartesian. Unfortunately, the calculator does not have a feature that can convert from polar to Cartesian that I know of. If there is a feature, please put it in the comments. So we can just do, we have to convert it to Cartesian. And we know to convert to Cartesian, there's the x component, there's the y component. We know the x component is r cosine theta, and we know the y component is r sine theta. Okay, here's an important note. They said opposite. What does opposite mean? Okay, I think, Anna, for me, I remember I did, let me see if it works. 73 cosine negative 49. Yes, it doesn't work. Okay, you have to use this way. If they tell you opposite, you add 180 to the angle. Let me show you. Theta equals 49 degrees. This is how it looks. What's the one opposite to it? Obviously, it will be this one here, right? And how did I go from here to here? I added 180 degrees. Okay, so whenever they say opposite, you add 180 degrees. So 180 plus 49 will be 229 degrees. Okay, and we know r cosine theta, so we'll do 73 cosine 229 minus 47.8, which is rounded to minus 48, and then 73 sine 229 will be minus 55, which is rounded to minus 55. Then they say a position vector perpendicular to r and located above the x-axis can be given in polar coordinates as r equals 1 and theta equals 139. To help you understand this, I'm going to draw it for you. Again, I'm going to draw this vector they gave up here. R 73 and 49 degrees. This is 49 degrees and then 73. R equals 73. Okay, they want it to be perpendicular. So we need a vector that is perpendicular to this line here. Obviously, we can make two right angles. We can either make it like this, right? And get this right angle. And we can either get this over here and get this right angle. But they gave us the case that it's located above the x-axis. So since it's located above the x-axis, we can only take the first case. What will this angle be over here? Very, very, very easy to find. Now we know this angle is 49 degrees, right? We know that this angle is this 49, right? Plus 90. We know this angle over here is 90, right? So we know this is 90 and this is 49. So obviously the total angle will just be 90 plus 49, which is 139. Okay, so do you want a simple way? We can always give you simple ways. If you know it's perpendicular and it's above the x-axis, you just add 90. But if it was below the x-axis, yeah, I just did it now in my head. If it's below, if they said below the x-axis, you do 360 minus this. Okay, but I don't think they will ask this. Question 12, I think بلشنا بالequations. No, still. Okay, distance. The distance between these 2 points. Like I told you, very easy. And I got used to it. خلاص. x2 minus x1 minus 1 minus 3 is, you can just say minus 4 squared. Fast. Minus 1 minus 3 minus 4 squared. Plus the other one. 2 minus 6. Quickly. 8 squared. You do this on a calculator, you get approximately 9. You don't get exactly 9. Okay. The x component, this is the distance formula. Distance formula is radical x2 minus x1 squared plus y2 minus y1 squared. Okay. The x component of the parametric equation. Okay, blah, 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 blah. Okay. They gave us 2 points, point A, point B. Hala, they want the equation of this line R, right? They said a line R passes through these 2 points. They want the x component of the equation, so the I, this is the I part. And then they want the y component, so they want the j part. How? Let's solve normally, and then we'll see x component, y component, وما بعرف شو. What's the first step? We write down the formula. We know when passing through 2 points, the line, let's in this case, line R, is equal to the first point A plus T. Remember, we always have the T outside. Second point minus first point, B minus A, right? So the first point A, which is 3i minus 6j, 3i minus 6j, plus T times B minus A. B minus A will be the x of B minus x of A, so minus 1 minus 3 will be minus 4i. And then for the j part, it's going to be, again, the j for the B minus j of A. So 2 minus 6, which is 8. So 8j. What did we say we do? Our answer has an I component and it has a j component, right? What is the I component? You take the first one, 3, plus t times the second one, minus 4t. Then for the j component, you take the first one, minus 6. Then you take the second one, t times 8, 8t. So let's look at our x component, the I component. To answer this, we have 3. And what's the one with t? Minus 4. I don't know why they took t out. Minus 4t. Then for the y component, we have minus 6. Then what's the one with t? 8. Okay? Question 13. Okay, line R is given by 2i minus 6j. What is a vector perpendicular to this line? Okay, remember, when you see perpendicular, they asked about it 2 times in this quiz. I'm sure they will bring it once. Remember, when you see perpendicular, that means when you multiply this vector r by the other vector, say u, okay, you get 0. What is the rule for multiplication? a1 times a2 plus b1 times b2, right? Or you could say x1 times x2 plus y1 y2. Let's see. They gave us the x component for the second line. All we need to find is the y component. So let's substitute. We know that it's supposed to be equal to 0 because it's perpendicular. So let's start substituting. x1, x2, so 2 times 6 plus y1, y2 minus 6. Do we know what y2 is? No. We know that it has to be equal to 0 because they are perpendicular. So 12 minus 6 times y2 equals 0. You could take minus 6y2 to the other side. You get 12 equals 6y2. You divide by 6, you can get y2 equals 2. So your answer will be positive 2. Question 14. I love 14. Wait. A day tool is recording. Oof, 50 minutes. Ya Allah. By the way, you're gonna have to get used to recordings being this long. Anything, Anna, what I record for you now is what you have to study. I won't be recording only quiz because you cannot depend fully on the quiz anymore. Okay, really. A line L passes through a point A and is parallel to vector D of magnitude 65 and bearing 166. Remember, we have two equations for lines. We have the equation that we used in the question previously, that was for 2 points, which I like better, it's easier. And then you have the equation for 1 point, and then the equation of the line of the other line. In this case, Sarah, they're being a bit annoying. They didn't give us the equation of the line directly. They gave us the polar coordinates of the equation of the line. So like, they're trying to be annoying. Can we find it? Yes, we can. We know if the magnitude of it is 65 and the bearing is 166. We can find the x component. We can find the y component. How do you find the x component? 65 cosine theta. If you put theta as 166, you will get 0. Why? They said bearing 166. Now, do we work with bearings or do we work with normal angles? We work with normal angles. Bearing 166 هيك شكله. هيك. Okay? هيك 166. هيدا bearing of 166. أنا بدي angle هيك شكله هيك. So, simply to find the actual angle, how can you do it? Let me see, wait. Yeah, I came up with a rule now. To convert from bearing to normal angle, just do 450 minus the bearing. Okay, and it will always work. You're gonna get 284. Okay, 284 is my theta. This angle here is 284 degrees. So now I have theta, I can directly find the equation of the line of the other one, right? 65 cosine theta and 65 sine theta. So 65 cosine 284, we said, and 65 sine 284. Let's see. 65 cosine 284. 65 cosine 284. You get 15 point, let's say, we round it to, let's keep it as 15.7. 15.7 I. And then for the y component, it will be sine 284 minus, we could say minus 63.1. Minus 63, or let's just say minus 63G. Okay? So this is now the equation of the line. Remember, to find the equation of the second line. Remember, to find the equation of the line with 1 point given and the other line, we know that the equation of the line, let's say in this case it's L. The equation of the line L is equal to the first point, in this case A, plus T times the other line, in this case it's D. Okay? Can we find it now? We have the first point and we have the equation of the other line, right? Can we find it? Yes, we can. Line L will be equal to the first point. 30 minus 62, 30I plus شو plus قصدي minus 60J. Minus 60J. Then we have, let's move this to the right. Then we have plus T, right? Plus T times the other line, which is 15.7 minus 63J, right? I have 15.7i. What did we say our answer always has to have for finding lines? An I component plus a j component. What is the I component? Remember, you take the first I, which is 30. Then you take, you only take the 30, you don't take the I. Then you take the second one. The second one will be t times 15.7. So 15.7 t. Then for j, what's my first j? Minus 60. What's my second j? T times minus 63 minus 63 t. Okay. What is our answer? Again, they're asking for the x component and the y component separately. What's the x component? Oh, which we have 30. We put 30. Then what's the one with t? 15.7, but here they rounded it up to 16. Then for the y component, we start with minus 60, minus 60. Then we have, what's the one with t? What's the one with t? Minus 63. So we put it here. Question 15. Lines r and t are given by 3 plus 4r. I and 5 minus 3r j. And 1 minus 2t, 2 plus 2t j, whatever. What is the x coordinate of the point where they intersect and the y coordinate of the point where they intersect? Here's the keyword, intersect. When they intersect, that means there's one point in common where they both have the same x and y coordinate. So whenever you see intersect, you equate the x coordinates and you equate the y coordinates. So you're going to put 3 plus 4r equals 1 minus 2t. You're going to put 5 minus 3r equals 2 plus t. You can do this on the calculator or you can do this on paper. Not all calculators have the equation mode, so I'm going to explain the way you can do it on paper. Then you can skip if you want to the calculator way. If you don't have this equation mode after you press mode, then continue watching, so I show you how to do it on paper. To do it on paper, you have to simplify. Okay, you take this one to the other side. It's gonna become 3 minus 1 is 2 plus 4r equals minus 2t. Then you divide by minus 2 on both sides. You're gonna get t equals 2 divided by minus 2 is minus 1. 4 divided by minus 2 is minus 2r. Okay, then down here, 5 minus 3r, you take 2 to the other side. You're gonna get 3 minus 3r equals t. Right? So you're gonna get 3 minus 3r equals t. Okay, then you have these two, right? T equals 1 minus 2r, and t also equals 3 minus 3r. So doesn't that mean 3 minus 3r is equal to 1 minus 2r? Yes, so 3 minus 3r equals 1 minus 2r, minus 1 minus 2r, huh? Can you solve this? Yes, you can. Minus 1 to the other side becomes 4. Minus 3 to the other side becomes r. You're going to get r equals 4. Okay, now that I have r, can I just find t? Yes, we know that t equals minus 1 minus 2r. So since it equals minus 1 minus 2r, t equals minus 1 minus 2 times 4, which is equal to minus 1 minus 8, which is minus 7. Should minus 7 as they minus 9. Minus 1 becomes minus 1. Minus 2 times 4 is minus 8, which is minus 9. So t equals minus 9. Now that I know what r is and I know what t is, can't I just substitute them into my x coordinates and y coordinates to know what my x is and what my y is? Yes, I can. How to find the x coordinate? Just substitute here. 3 plus 4r. We know r is equal to 4, so 3 plus 4 times 4, and you get 19. And then for the y coordinate, can't I just substitute again? R equals 4. 5 minus 3 times 4. You're going to get 5 minus 12, which is minus 7. So you get 19 here, and you get minus 7 here. Logically, you're supposed to check that when you substitute on for the 1 minus 2t and 2 plus t, that you get the same numbers. In this case, you do, and I can show you that you do. 1 minus 2t, 1 minus 2 times t, which you know is minus 9, is going to be 1 plus 18, which is 19. And then 2 plus t, 2 plus minus 9, which is minus 7. So you do get the same answer. This is just to prove that they intersect. Okay. If you have a calculator, you can do it this way. Again, write it down, equate them to each other. 3 plus 4r equals 1 minus 2t, the x component to the x component, and the y component 5 minus 3r to the y component 2 plus t. Now, when you do this, you want to take all the letters to one side and all the numbers to one side. You can do it like this. You can take the 5 over here and take the t here. You can get t minus 3r, and you take the 5 here, it becomes minus 5, right? So 2 minus 5 equals minus 3. This is for the first equation. Then for the second equation, take the t here, it becomes positive 2t, right? Positive 2t plus 4r. And then 3 there, 1 minus 3 is minus 2. So isn't this a simultaneous equation? Yes, you can just do it on the calculator. Equation mode, 5 equation. You take the first one, ax plus by equals c. Okay, the first equation we have t, so 1, let's call ta, right? 1 equal minus 3 equal, then minus 3. Then for the second equation, 2, 4 minus 2, then you press equal, you get, oh, what did I do wrong? What did I do wrong? 1 minus 3 minus 3, 2, 4, I did something wrong, wait. Yeah, I made a mistake. Here, when I moved t to the left, it becomes negative, so it should be negative t. So here should be negative 1 instead of 1. Negative 1, and this should rest, yes. Yeah. So x, which in this case is my first number, which is t, is equal to negative 9. So you get t equals negative 9. And then what is my r? 4. And then after this, you can just substitute and you can get these answers. Okay, I think 16 is the last question. Yes, okay. You have two vectors. Let's find the scalar product. Very easy. We know the scalar product is x1, x2 plus y1, y2. So 24 times 4 plus 7 times minus 3. And you get 75 because 96 plus 21, 96 minus 21 is 75. The angle between these vectors to the nearest degree is, okay, this is where I told you, remember there's another formula for the scalar product. The other formula is magnitude of A, magnitude of B, cosine theta to find the scalar product. So this is just another formula. But they said a1, a2, so x1, x2 plus y1, y2 is easier. So that's why they used this formula to find the scalar product. But sometimes they're going to ask you for angle. So that's why you need to know this formula as well. To find the scalar product, you can also do magnitude of A times magnitude of B times cosine of that angle, angle in between. What's the magnitude of A? 24 squared plus 7 squared. Let's do it on a calculator. Radical 24, mode 1. Radical 24 squared plus 7 squared. You get 25. It's 25. And then the magnitude of B, 4 squared plus 3 squared is 25. Radical 25 is 5. So 25 times 5 times cosine theta equals the scalar product. Do we know what the scalar product is? Yes, 75. Okay, 25 times 5 is 125. Cosine theta is equal to 75. Can we find theta? Yes, we can. Just divide by 125. You get cosine theta is equal to 75 over 125. You get theta equals shift cosine of 75 over 125, which is to the nearest degree 53 degrees. Okay, now OC is the median of the triangle OAB. Its coordinates to the nearest integer are what? I'm going to draw it for you so you can easily understand it. Okay, OA is 24i plus 7j. So you have, let's say 24 is over here, 7 is up here. So it's somewhere like this. Right? We can call this A. And then OB is 4i minus 3j. So let's say 4 is over here. It's 4 minus 3 is over here. This is OB. They're saying OC, okay, is the median of the triangle OAB. So this is O. O is the origin, by the way. We know the triangle OAB will just connect these two sides, right? It's OC is the median of the triangle OAB. So O connected to point C is the median. Median of any triangle means it's a line that splits this segment into two halves. So can't you just say that in this case, OC, right? It splits this into half and half. So can't you say C is the midpoint? It's the midpoint, right? And isn't there a formula to find the midpoint? Yes, we have a formula. So we want to find the midpoint of the segment AB, right? And how can we find the midpoint of a segment AB? Do we know the coordinates of A? Yes, 24, 7. Do we know the coordinates of B? Yes, 4, minus 3. So can I find the midpoint? Yes. We know that the midpoint of any segment, it's x1 plus x2 over 2, comma y1 plus y2 over 2. x1 is 24. x2 is 4 over 2. y1 is 7. y2 is minus 3 over 2. Solve it. 24 plus 4 over 2 is 28 over 2, which is 14. We could say 14i. This is my x coordinate. And then 7 minus 3 is 4. 4 over 2 is 2. So 2j. 14i plus 2j. That's it for the quiz. Let me take a look at the course revision grids. So this is in SDP. It has its own course revision document. Mechanics. I'm gonna go through it with you quickly. You have 1, 2, 3, 4, 5, 6, 7 grids. We can go through quickly. Describe how to geometrically add two vectors denoted u and v. I'm gonna look at the solutions. Okay, the initial point of v coincides with the terminal point of u, so the sum u plus v defined as vectors. The initial point is that of u, and whose terminal point is the terminal point of v. Remember, they use the triangle method. So they're saying the initial point, see, we're saying u plus v, right? The initial point of the second vector, so yani the tail of the second vector, should coincide with the terminal point of the initial vector. So the head of v should coincide with the tail of u, like here. This is the triangle method. And then the sum of them will be u plus v will be the vector whose initial point starts at u and its final point ends at the final point of v. You see, so the initial point of it starts at u and its final point ends at the final point of v. That's another way. In case, like they put fill in the blanks, just know what to fill in. And then, akid, which of the following? It could be this one or the one in the quiz. Question 6. I and j, okay, blah, blah, blah. This is a very easy question. I will show you my way because I don't like the solution here. Let me see, I need to find AB as follows. AC is AB. Wait. Okay, and I really don't like the solution here. I'm going to show you my way. Okay, you have point A, which is 4, 7. You have B, 3, 5, minus 5. And then they gave you the vector B, C. So we have point A, B, and now they gave us vector B, C. So there's a third point C, but we don't know what the exact point is, but we know the vector. And then they want us to find AC. Okay. AC is between the point A and point C. So you know that AC would just be the x of C minus the x of A, then the y of C minus the y of A, right? That's vector AC, final minus initial, final minus initial. So if I can find point C, I can find AC directly. They did it in a different way. They used the sum of vectors. I'm going to show you my way. Okay, we know vector BC is 5i plus 9j. They gave it to us. BC is 5i plus 9j. Okay, we know that BC, it starts at B and it ends at C, right? What is B? Point B is 3 minus 5. So don't you think I can find what point C is if I just apply this vector to point B? So like, look at this. Let's say you have point B. Point B is 3 minus 5, so it's down here. Okay, this is point B. And I apply this vector 5 to this 5i means go 5 to the right, 9j means go 9 up. So isn't this the same? This is what BC looks like, right? So don't you think if I just apply the vector to point B, I add the vector to point B, I can get to point C? Yes, because it's vector BC. So I can find what C is, x of C and y of C. I can find what it is if I just add this vector to point B. So 3 plus 5 is 8 and minus 5 plus 9 is 4. So C is 8, 4. Very easy. Now I know what C is. I know what A is. Can I find out what AC is? Easy. Final minus initial. So the x of C, which is 8, minus the x of A, which is 4, and then the y of C, which is 4, minus the y of A, which is 7. 8 minus 4 is 4. 4 minus 7 is minus 3. So AC is equal to, because they said in vector notation, yani I and j, is equal to 4i minus 3j. check if this is the correct answer. 4I minus 3J. أكيد centimeters because they want the unit. Now, next. Question 8. A vector force F is given by 3I minus 4J. What is the magnitude of it? أكيد magnitude you do radical 3 squared plus 4 squared, which is 5. Okay, I won't give you a solution. Very easy. Define unit vector. Okay, these basic questions, I'm going to let you go through the solution yourself. I will only solve the one BG because basic grid. Okay, given two forces, there's question time. Question time. Find the magnitude R and direction. Remember, you can just put it on the calculator. You can do pole. You're going to get that the magnitude is 10 and the angle is 53 for this one. I'm not sure about this one. I'm not in the mood. But just do shift pole and then put in the coordinates like I showed you earlier. For those of you who are just watching for the grids, you just do this pole 6, then you go comma 8, gives you R and gives you 53. Okay. Basic grid. Given two forces F1 and F2, find the magnitude and direction of the resultant of R and F1, F2. This was in the quiz, but let's see. The resultant means you add up the I's and the J's. Add 7 plus 8 newtons, you're going to get 15 newtons I. And then for your J, it will be 9 minus 12, it will be minus 3 newtons J. So this is the resultant. What do they want? They want the magnitude and the direction. Direction, yani they want the angle. Okay. Can we find the magnitude of it? Basically, they're asking us to convert it into Cartesian, right? So how do we find magnitude? We do radical 15 squared plus 3 squared, right? Radical 15 squared plus 3 squared. You get 3 radical. Is this correct? BG12. RTF. The magnitude of the resultant R and this direction. Yeah. Oh, they solved it here. Wow. How did they get 21? R F1 plus F2. 7 plus 9. Okay, I. 15. Okay. Did I read it wrong? 9 plus 12. It's minus 12. Okay, I think it's a typo error. Here it says minus for me. I think they meant plus. Because in the solution they used plus. So let's work as if it's plus. 21 J, because 9 plus 12 is 21. Okay, and then if you calculate the magnitude of that, 15 changes to 21. You still get 25.8. Is this 25.8? Yes, okay. So the magnitude of it is 25.8. Then how do you find the angle? Remember, since it's x is positive, you can just do shift tan y over x, so 21 over 15. And you get shift tan 21 over 15. 54.4. Is it correct? Okay, 54.5, same thing. Are we done? بعد في واحدة. Okay, given A is 12 kilometers east. What? Oh, okay. A is 12 kilometers. And the angle of it is east 60 degrees south. Okay. And then B is 20 kilometers and its bearing is 300. Find A plus B in terms of I and J. Okay, if we want it in terms of I and J, that means we have to convert each one to I and J and then add. So I'm actually going to take this to the open board because I want some space to draw. Okay, let's draw our planes. Okay, we're going to see here. East, this is north, south, east, west. East, 60 degrees south. So we go to east, then we go 60 degrees downwards because he said south. So it's going to look something like this. Right, this is A. We know it's 12. And this is 60 degrees. Okay. B is 20 kilometers and it's a bearing of 300. Remember, here they didn't really say anything. They just said bearing of 300. So you go 300. This is 90, 180, 270. So it's going to be somewhere here. This is about 30 degrees. So this over here is 300 degrees as a bearing. And this is B. We know this is 20 kilometers. Find a plus b in terms of I and j. So here we have magnitude and angle. We want to convert to I and j. Remember, to convert to I and j, we need r cosine theta and we need r sine theta. What do you do when you have bearings? Right now we're working with bearings, right? This is 60 degrees. What's its bearing? Is its bearing 60 or is its bearing 150? It's 150, right? Because the bearing starts at north. Go north. You go down to the angle. This is 90. You go down plus 60, 150. Always draw. If you have time, it's always better to draw. For these types of questions, draw. Okay? Draw so you can picture what's happening. So this bearing here is 150. What did I tell you you do when you have a bearing and you want to convert to a normal angle? You do 450 minus 450 minus, yeah, you do 450 minus the angle. So in this case, our angles are by minus the bearing. So you do 450 minus the bearing, which is 150. You get that theta is 300 for the first one. So we're going to do r, which is 12. The magnitude is 12 cosine 300. Okay, and then as I plus 12 sine 300 j. This is for the first one. Now for the second one, we know that the bearing is 300. So how do I find the normal angle? Again, you do 450 minus the bearing, which is 150. So you're gonna get the angle for it is 150. So we're gonna do the magnitude times cosine the angle. So 20 cosine 150 I plus 20 cosine, shoot 20 cosine 20 sine 150 j. Okay. From here, this is where we need our calculator. I have a calculator, I think, here in applications, calculator. It's somewhere here. Yeah, there you go. Do I not have sine or any question? Mantle. بدي scientific. ما في scientific. Okay. عادي ما في scientific. 12 cosine 300. Let's just get it. 12 cosine 300. 12 cosine 300. 6. So we're going to rewrite this as 6. I. 12 sine 300. Minus 6 root 3. J. 20 cosine 150. It's minus 10 root 3. And then 20 sine 150. 10. 10 J. So A plus B in terms of I and J. I don't know why I have a small feeling I'm doing something wrong. Let me go down. They used 60. Wait, let me see. Yeah, they got the same answers as me. So for the first one, we got 6i minus 6 radical 3j. And for the second one, we got minus 10 radical 3 I plus 10j. Yeah, and then obviously when you want to add them together, we add the i's together and the j's together. So 6i minus 10 plus minus 10 radical 3, we just keep it as 6 minus 10 radical 3 I, right? And then no, is it? Yes, yeah. And then for the j's, we do minus 6 radical 3 plus minus 6 radical 3 j plus 10j. So it will be minus 6 radical 3 plus 10 j. I think that's it for this. Yes. Okay. We're done the grids, but one more question I saw. I didn't mention it. It wasn't in my notes. In case they ask you, where is the mariner's compass? Here. I solved this question, but I didn't explain how they ask the question. They say mariner's compass. Mariner's compass is when you say south 30 degrees west, east 30 degrees north, east 45 degrees south, west 26 degrees north. All these terms I just said, that's what mariner's compass means. Okay, like this, that would be everything you should have to study for mechanics. If you study everything in this video properly, you should get 100. Seriously, you should get 100. Thank you so much for watching, and good luck.